Hello, world. Today, we're going to be doing a mock coding interview with a ex-Facebook engineer known as Ardman. He also is the creator of the front-end expert aspect of Algo Expert, and you can see a link to his YouTube channel right here. If Just in case you guys don't know who I am, because this is my first video, I am a first-year computer science student in Dublin City University, and I'm also a incoming software engineering intern in HubSpot, which I'll be doing in summer. And I'm just using this channel to just share my experiences throughout my software engineering career. Obviously, I'm in my first year only, but I'm going to be sharing my experiences along the way, as well as try to give advice to some people that are just starting up, just to get people onto their feet kind of thing. And yeah, I hope you guys enjoyed this video. If you want to see the part one of this video, will be on Ardman's channel, and I will link the video down below in the description. And hope you guys enjoyed the video. If you guys do, make sure to subscribe and like, and let's get into it.
Patrick, are you ready for your second question?
Yes, indeed. Let's see how this goes.
All right. So this question is called max subset sum, no adjacent, which I know is a bit of a mouthful, but the actual question's pretty straightforward. So we have a sample input, which is an array of integers. And what we want to do is return the maximum sum we can get by not using any adjacent numbers. So nothing that's touching each other. So here the answer is 330, which we get by doing 75 plus 120 plus 135. So those are the three numbers we use, and that's sort of the maximum we can get by not using any numbers that are next to each other in the array. Does that make sense?
Yeah, it does make sense. Yeah, okay. So we're just trying to see the maximum sum, provided we don't choose any adjacent, we don't choose any adjacent numbers. Yeah.
Yeah. So, for example, if we want to use the number 120, we are not allowed to use 105 or 75.
Okay. And this is will there always be wait, sorry. Oh, we're just returning the maximum sum. Oh, okay. Okay, no problem. Yeah, so what jumps out to me immediately is, say we start at the 75. If we want to choose the 75 in our sum, we can choose that, and we can choose the maximum across so I'm going to call this recursively. So we choose the 75. If we choose the 75, we choose the maximum from index 2 onwards. We call the function on that again, which is going to do the same
Mhm.
thing. It's going to either choose the current as well as from index 2 onwards, or it ignores that current and just checks the index 1 onwards,
Okay.
if you know what I'm saying. So that's what the function will do. Is, okay, for 75 we can either choose 75 and continue to add. So we're going to choose 75 and plus the obviously the max sum from the array from index 2 onwards, just skipping the adjacent number. And or we don't choose 75 and we just choose 105 onwards,
Okay.
and we run the same function on that. It's going to keep track of the first number. We either go to the second onwards, or we ignore the first and we go from 1 onwards. Do you understand what I'm saying there?
Yeah, I think that makes sense.
Okay, so I'm going to explain further as I code it up, but well, the recursively, I think this is going to be pretty bad in terms of time complexity, but I'm going to see how I'm going to memorize this as I go on.
Okay.
Okay, perfectly. So I guess our base cases, hmm, if our current index,
Well, let me ask you this before
if
you start coding,
yeah, go ahead.
actually. Um,
But
do we so I think what you described definitely makes sense. But I think it might simplify things a little bit. Do we necessarily well, I was gonna say, do we need to do this recursively? And if the answer to that is no, it might actually, I think, help with what you mentioned of memorization. This definitely can be solved recursively, though, if that's the route you want to go.
mhm.
But I think
I yeah.
oh, go ahead.
Well, wherever there's a the wherever there's a recursive approach, there's always some tabulation that I can do instead of the recursive backtrack, not backtrack, just a recursive approach. But for now, I just want
Mhm.
to go through with the recursive and then see how I can optimize in terms of space and time as I
Okay,
go on, if that's okay. Yeah.
that's fine.
Okay. So the indentation here is pretty okay. So
I think it's
now,
indented one time too far. So hold
yeah,
on.
it is. That's what I was thinking.
Yeah, so yeah, there you go.
Okay, perfect. So I guess one of the base cases is when if our array is nothing. So if say we're on index 135, then we try to call it on from an index that's out of bounds. So then it's just going to call the function with an empty array. It should. Yeah, it will just call the function with an empty array because we're trying to say um, array from index 0, 1, 2, 3, 4, from index 5, from index 6 onwards, or I think some 7 onwards, which will just be an empty array in Python. I think that would just give you an empty array if the index is out of bounds.
Yeah, I think
It
it
would, yeah,
does.
it would just give an empty array. So then, if it's an empty array, I'm just gonna return 0 because we can't take anything from obviously an empty array. So
Yep.
if not, we are going to return 0. And if okay, we do have an array. Now we're gonna return. What we're gonna return is the max between if we were to choose the current number array, the first one. If we choose the first one, we add it to the max we can get from index 2 onwards, so skipping the adjacent one. So we're going to see, oh, this name is pretty long. Let me just copy it. Jeez.
It's a wordy
Next to
one.
adjacent. Yeah. Array from the index 2 onwards. So we're skipping the adjacent one. So we're getting the max between that. And if we were to just get the max skipping the current index, the current first number. If we just skip that and just call it on the rest of the numbers, we get the max there because that could potentially be the max. And we return so we just call again on one array from 1 onwards. So what this does, we either choose the current the first number and we choose the max we can choose from the skipping the adjacent number, and or the if you were to just choose we were to skip that number and go with the rest of the array, that will return our maximum sum, pretty sure.
Okay,
Yeah.
cool. So let's get rid of this. I'll just delete this pass that was here. Um, cool.
I just have one thing, sorry. Just thought of another edge case there. If the length of the array is 1,
Yep.
if the length of the array is 1, I just want to return that number straight away as well instead of going into unnecessary 2 more calls.
Yep.
If that array equals 1, then we're just going to return array at 0. Just wanted to make sure. Is 135 is not considered adjacent to 75.
135. No, it is not.
Okay, cool.
Yeah, it
So
doesn't like loop around.
okay, that's just wanted to make sure. Yeah.
Cool.
Yeah, I think that covers it. Yeah.
Cool. Do you want to? Let's maybe first test this with a few inputs, and then we can see about
Mhm.
trying to optimize
Yeah,
things.
no problem. This is the okay. Let's say 10, 20, 40.
Okay.
And let me not get too big because then I won't be able to compute in my own head. 10. So here we could
It'll
either
tell you what
choose.
the expected output is as well. Whenever
It
you
will, yeah.
run this, it'll run it with the correct solution as well. So it'll tell you.
Okay, code
So
passed.
yeah. So
Well,
this one.
this one passed. I think let me just go with 100 now, and that was 1. Yeah,
120.
perfect.
So 20 plus 100. Cool. Yeah,
Mm-hmm.
I think logically this makes sense.
Mm-hmm.
But now the uh the the time complexity. What are we thinking about this? And can we do
Oh,
anything to try to optimize things a little bit?
oh, there's definitely something. I'm thinking, what is dynamically changing here, which we can use to identify where we're running into another subproblem we've already encountered. So,
Yeah.
say we choose 75. Um, if we choose 75, we're going to run it on index 2 onwards, so we're going to be at 120. So that's going to do. So that's going to okay, run the function on 120, right? Cool. Now, if we were to ignore 75 and go to 105 and ignore 105 and go to 120, it's going to do the entire thing again on 120.
Yes.
So that's the sort of problem that we need to stop. So what we can cache is the current array. So I'm gonna have a cache with the key being a tuple containing each element in the array, and um and the value being the what the result was here. So like it'll kind of be like a memo tuple, because you can't use arrays as a keys of a hash map. I'm pretty sure in Python you can't anyways. Tuple array is equal to, so it's going to calculate the max for that specific input.
So why do we
And
need a what
yep,
is the tuple for again?
the tuple is okay. So we're calling the function on this specific array, holding let's say here we called it on the 120 onwards. So we'll be holding 120, 75, 90, 135. So we've already cached the result for that specific array, because we found the max that we can get from that specific array. So now when we go through again and we hit 120 again, the array is going to be the same as what's already in the cache, and we just return the result straight away. You know,
Right.
I'm kind of just
So
caching
what if
inputs.
I'm not sure if this is specified in the problem or not. I don't think it is. So what if there were two copies of 120? So what if there was 75, 105, 120, 75? So see how we have two versions of 75?
Yeah,
When we get to the second 75,
yeah.
are we going to have an issue there?
We won't, because I'm keeping track of the whole array and not just the number.
Oh, I see. So
Yeah.
it's
So I'm
so
basically just
I guess
yep.
could you clarify what exactly is in the memo array? I might have misunderstood.
So the key is going to be essentially the inputs we're giving to the function. So
Okay,
for this
so
specific array, it's going to calculate the max we can get for that specific subarray. I'm just going to say subarray. For that specific subarray, we're going to get the max of that. We're going to store it in the cache. So if next time when we're going through our recursion, we encounter that specific subarray again, we're just going to return the max we already gotten, instead of calling it again on the entire array. If you know what I'm saying.
okay, yeah, I think that makes sense. Let's see. Yeah,
Uh,
maybe try to implement it and we
yeah,
can see
no
from there.
problem. Okay, memo. And I think I'm gonna have to slap this whole thing into a helper function.
Okay.
Um, how do I like tab the entire thing?
Highlight it all and then hit the tab key.
Oh, it does that.
Yep.
Been a developer and I didn't even know that. Okay, def. I'm just gonna say result. R. Just gonna change it up a little bit. So I'm gonna call it on the whole array. Okay, call it on the whole array. If not R, and then we're gonna return memo at. Okay, I'm just gonna say inputs is equal to tuple R, because I don't want to. What's it called? Call tuple like 3 different times. You know what I'm saying?
Okay.
So I'm gonna put that at the top. Oh no, right after the if not array. Yes. Sorry, right after this.
Yeah.
So I just went back to where I started. Okay, cool. So inputs, memo inputs, and then we're gonna return memo inputs. And I'm gonna change the name of this entire thing. Results. I think that is the whole memoization.
Was result. Wait, what is
Oh, yeah.
result on
Oh,
line
I didn't
9?
call it. I didn't call
Yeah.
it. Sorry, I didn't call it. Is that on the
Oh, I
right
see.
line?
Results the name of the function. Okay, yeah.
Okay, results.
And then
Hold on a second. So
yeah.
this is going to be in here, and then we're going to return the. Oh, sorry, this thing just lagged. And then we're going to return this
Cool.
as a result. Yes, I think that's it.
Cool. And
If got the if statement. We need the if statement in there. If inputs in memo, return memo inputs.
All right. Yeah, I guess we need to use our memo for it to,
Yeah, just made it without
do
using it.
anything. Cool.
Just making sure we don't have any other issues here. Tuple R inputs equals tuple R return memo inputs. Yeah. So we're just storing it in a cache before we return the result. Yeah.
Mhm.
Then return result array. There was an issue. Is this indentation?
The
Or...
output, invalid syntax.
Oh,
I think you're
didn't put a
missing
colon.
the colon. Yeah.
Yeah. Test case 1 is passed.
Cool.
Okay, the code passed. And we're like, you're gonna run it on the whole thing?
Yeah, we can if you want. So if we go to tests and then run code, yeah, so it passes all the test cases. Cool. So let's talk about the time and space complexity of this version, and then there might be ways we can optimize a little more too.
Okay. In terms of time, I'm gonna bring up a case here. Can I not see the cases, other cases, or can I only see my own?
Yeah,
cases?
you can. So if we go to test and then you hit the little eyeball icon.
Oh. Okay. So, okay, let's say we process 75. We take 75 and we process everything for 120 onwards. Once we've processed 120 onwards, we have that result stored. So if you try to process 120 again, it's just going to return the result. So that will make the time complexity go down to linear time.
Okay, so essentially what you're saying is we are doing this like process step one time for each element in the array?
For each element in there, we are doing the process only once.
Okay, yeah. Yeah, I think that sounds right. Cool. And what about the space?
In terms of space, we are storing in our memo, we're storing the results of every output. So for every single input. So it will also be linear space as well.
So what are the keys and values in that?
Oh yeah,
Memo?
we are kind of holding every sub array. So let's say, yeah, the key is the inputs and the value is the result that it gave. So in our hash map, we will have the entire array as well as no, not the entire array. We'll have the entire array as well as it cut down by 1, as well as it cut down by 1, as well as it cut down by 1. So it's kind of like so it is still linear space. Well, it would be like n plus n, I think it would be. I think it would be n plus n, yeah.
How many
The worst.
how many entries are there in the hash map?
1, 2, 3, 4. In the hash map, we will have 1, 2, 3, 4, 5. We'll have 6 entries, 5 or 6.
Yeah. So, or with regard to n, that is roughly
that's
n, right?
So linear space, yeah.
So there's n entries in the hash map, and for each entry, we have a key and a value, right? And what is the size of that key and value in the worst case?
The size of the key in the worst case is n as well.
Right. So if we have an array of size n, and each element in that array, or not an array, sorry. If we have a hash map of size n, and each thing in that hash map has a potential worst size of n as well, then what would that give us, like, total?
And okay, the worst, the hash map will have everything. It will have n, then n minus 1, then n minus 3, n minus 4, n minus up until 1. So I think it's still linear.
So
but
when we have
could be wrong there.
Yeah, so one way to think about this hash map is almost as it's almost like a nested array, right? Because it has size n, and each element of that, and each of the n things is also an array, right? Because they each have an array for a key. So if we have n arrays of size n, which, I mean, they are really size n minus 1 and minus 2, like you said, but time complexity wise, we just kind of look at the biggest one. It's going to end up being n times n, or it's going to be n, sorry, n elements in the hash map, each of size n is going to give you n times n, or n squared, essentially, right?
Okay, so n squared space. Okay.
Right. So,
Okay, I
and
understand
that's
what you're saying there.
because we have those arrays in the hash map. So, sort of what I'm getting at is there a way to make our hash map, or to have our memorization in general, regardless of how it's stored, is there a way to not have our memorization take up that much space? Like, do we need all of these arrays?
Oh, I guess I could just store indexes instead of the entire array.
Right.
That would be the deciding factor, because so that would also account for duplicates, because obviously this first one will be 0. So for starting at index 0, we got this answer. For starting at index, you can't see me highlighting the test cases, can you? I'm
No,
just
I
gonna
can't.
copy it. I'll just copy it and just put it up there. Can you see me in the sandbox? Yeah.
Are you in the which? Oh, you're in the sandbox.
Scratch pad,
Oh,
not the
scratch pad.
sandbox.
Okay. Yeah, sorry. There's a lot of tabs. Okay. Yep.
Sorry. Okay, so for this 75, for index 0, we're gonna call the functions and we're gonna store that memo, yeah? So let's
Mm-hmm.
go a bit further down just to save time. Now we're at this 75. Um, that index is not in the memo, so we're gonna call it and store the key being the index and the value being the results at that specific index. So then if we were to go again to 75, this index here will already be in the memo and we will just return the result straight away instead of calling the function. So I think that would work as well.
Okay.
So,
Cool. Can we maybe update the code to do that?
okay. Updating the code. Because right now I'm kind of slicing the
Yeah.
array.
So right now
So
you're like slicing the array,
yeah,
but we already
slicing the
have
array.
that array, right? Like all that. Um,
Okay. We already have that array. Okay. I think it will be, let's say we're at this 120 here.
yep.
That's index 01, that's index 2.
Yeah.
So the index will be so the index will be the length of the entire array minus the length of the current subarray.
The length of
So
the entire.
entire array
Oh yeah,
minus the
yeah.
current subarray, which will then give us the length of the first element there. Because in an array of length 6, the first index will be the length of the whole array minus the length of the whole array. So then in the subarray, the length of that subarray will be the length of the entire array minus the length of the subarray, which will then give us the index of the first element in that subarray. Does that math make sense?
I think so. I think you might
Yeah,
be
I think.
overcomplicating it a little bit. But
Mhm.
I think what you said is probably accurate. Um,
Yeah,
but if
it's kind of, yep.
so, our subarray is always just a subarray from some index to the end, right? It's like on line
Mhm.
11, we do result array of 2 to the end and 1 to the end of it.
Uh-huh.
So
Mhm.
do we need to be saving these whole arrays, or can we just save the index it started at, because it always goes to the end?
That is true. We could do that. We could do that. We are saving the entire array over and over again. Yeah. Yeah, we definitely could do that. So you're saying I just save indexes rather than the entire subarray. Because
Yeah.
we're gonna reach the end either way. Okay, yeah, we could do that. So I guess we can start this off with some sort of C, like kind of like sorry. Kind of like a cur. Then it's gonna be array. Oh. So cur. So we're just gonna call this on cur. So we're just going to hold the index. It's going to be the index, right? I'm just looping through if C is equal to len, I'm just going to do this line by line to just correct it. If C is equal to the length of array minus 1, then we're going to return array at 0 at C. Okay, that's as soon as we hit the end. Inputs, we're not going to need this anymore. If C in memo, return memo C, and memo at the current index is equal to, if we choose array at C plus if we were to call it on the current index plus 2. Exactly. If we were to call on the current index plus 2, or we just call it on C plus 1. We return memo C and call that on 0. I think so. And if not array, which would just be if C equals 0. Then return, wait, no, if C equals 0. Sorry. If not C, if C is equal to len array minus 1, if C is greater than len array, then we just return 0.
Okay.
I think that covers it. So the first, if C is greater than len array, that's covering if we go out of bounds. If C is equal to len array minus 1, that's covering if we're at the last element. We return array at C. If C is in the memo, we've already calculated for that index. We return memo at C, and we store. If not, we store memo at C equal to the max. If we were to choose the current array at the current number at array C, plus if we were to call the function on the current index plus 2 to ignore the adjacent cell, or we just call the function on every index after ignoring the current number. Does that make sense to you?
Yeah, I think so. You want to run it, make sure it still works?
Ooh,
okay.
Sticky.
So
Sticky.
So maybe if we look at, it looks like we're having a runtime error. So if you look at test case 1 and open it up, it says list index out of range on line 12. Or sorry,
I can't see the line 10. Is that what it says? Line 10.
Memo. Yeah, so it's it's the line where you're creating the. Oh, so I see. Line. It looks like results of 0. Oh, so at the end. Oh, I see. Sorry, you're calling results of 0, and then where's the index out of range?
A little bit of debugging here. Hold on. Using max array C plus result, C plus 2 plus result. Yeah. I thought I took care of if the index is out of range already.
So where is?
Oh, sorry.
Oh, go ahead.
Oh no, I was just thinking if the array was empty, C would not be greater than the length of the array. C would not be equal to that. C would not be, and then it would try to access array C. So okay, if not array. Okay, what were you gonna say? I don't think that covers it.
Okay.
But
Yes,
what are you gonna say?
Yes, I don't think that's gonna solve the main issue because like this is failing on most of them. So I do not spend a whole lot of time with Python, so I'm trying to understand this list index out of range. So so I guess the first thing is to see where is list index being used. Program.py line.
Oh, if C is greater than or equal to, or equal to len array. I think that should solve it.
Okay.
You want to run it now? Yeah. That's perfect.
Okay. Yep. There you go.
It's a minor thing. Okay, that's
cool.
Amazing. This brings it down to constant space rather than squared space.
Okay, so
still linear time. Sorry, not constant space. Sorry, linear space and linear time.
All right, cool. So I think this is correct. One small follow-up question. With our memo, since we changed it to the key is now an index, right?
Mhm.
So do we need a hash map necessarily, or could it be a simpler data structure?
Hmm.
And it won't necessarily change the complexity
Well,
analysis, but
it could just be an array. Yeah.
yeah.
We could just use an array and then like index one. So then it would be array index one would be equal to the max, and then if C, so then we'll have like if array at C is not equal to some number, like I start off with like -1. If array at C is not equal to -1, meaning that we've already processed that thing, we've already processed that specific index onwards, we would just return that number in the array.
Yes. Yeah. So I don't actually think anything necessarily needs to change in the code other than it can just be made into an array, right? Because the currently you have a hash map where the key is the index, and
Yeah.
that index is going to be anywhere from 0 to the length of the array, right?
So are you trying to say if I was just change the brackets here like this?
Yeah, I think it can simplify things
Yeah.
a little bit.
Yeah. The thing is, can't do that in Python.
You can't?
I know in JavaScript you can. It will dynamically, but in Python you can't change an index that's not there yet.
Oh, so yeah, I guess you would have to create an array of some size, right?
Yeah, -1 for I in range an array.
Yeah. Yeah, and I guess maybe you can make an argument that that's not actually simpler in Python land, but generally I think using
Yeah.
an array over a hash map is maybe a somewhat better, but I guess either way is fine.
Yeah, I understand. Yeah. Guess so.
Cool. And then also I don't know if you need that check above the memo. It's not really hurting anything, but
Yeah, exactly. Okay.
yep.
That's perfect right there.
Cool. Awesome. I can give you a little bit of feedback if you want it. And we can talk about this question and the one we did on my channel if you want. So and to be clear to like people watching, usually at the end of an interview, you usually don't get much feedback, but I think it could be helpful. So I think you did a good job. I definitely would have passed you in this interview, especially if it was for like an internship type position. With this problem specifically, your answer was correct and it works. On like the code itself, one thing I would avoid doing is using variable names like C, because they're just kind of confusing. So
Yeah.
the only single letter variable name I would really ever use is I, and maybe this one even should have been called I because it's an index, right?
Yeah, true.
So I would avoid that. And like in the other problem, I think we used L and R for left and right, and that can be fine because I think those along with I are pretty obvious. But ones like C, I would, if it's meant to be cur, I'd just write that out. The first question I think you had basically completely correct. This one is correct. There's one follow-up I was considering asking, and I chose not to because I think it would be too big of a change to do it. But there is actually a solution to this problem that uses ov1 space with the same time complexity. And essentially what it requires is rather than doing this recursively, we would generate our memo array iteratively. And sort of there's this trick that we use a lot in memorization and in dynamic programming in general, where we see, okay, we need this array of values, then we can calculate current values based on the previous values. But oftentimes we only need the one or two previous values, and then we can just not use the other stuff in that array. So we can keep the array of size 2. So kind of the idea here, and I don't know if this makes sense because the reason I didn't ask it is because it's backwards of the way you've solved it, which the way you solved it is fine. And I just think it's too much to ask. But
yeah.
But basically we would see, okay, we have 75 and the max subset at 75 is just 75, right? And then we'd say, okay, what if we added 105 to it? And when we add 105, okay, the max subset here is either 105 or just using 75 because they're adjacent. So it would be 105. And then we'd look at 120 and we'd say, okay, with 120, the max subset is either 120 plus 75 because we go back 2, or just 105 and whatever we had there. But then once we get to say like this 90 towards the end, the solution is 90 plus the solution at 120 or the solution at 75. So it's sort of a backwards version of the memorization you did. So instead of like looking forward and memorizing the future, we are looking backwards at just the previous solutions and building up the solution until we get to the end. And by doing that, you can just only keep those two values. So I just wanted to sort of share that for the video. If this was an actual interview, I wouldn't even mention that. And it would be one of those things where I'd still pass you for having a correct solution. But there's just sort of like a tiny little optimization that can be made if you sort of solve it in the opposite direction, if that makes sense.
Yeah. Let me just add one thing. Are you what you're saying there, that can be done in place as well, can't it?
Can be done in place.
Are you changing the number in place? So, okay, so we have 75, 105. That won't change, of course. Then we just go from 120. 120 would change to, if we were to add, are you doing it in place or are you doing it with a new array? Like a VP array?
In my mind, I was doing it with a new array. I can actually pull up the solution that we have on Algo Expert. So the solution on Algo Expert, so this one is linear and it is linear space as well. So solution number 1, if you can see that. And this one is similar to yours. It still works in the opposite direction, basically, but it's kind of a similar concept. And we can see we have this max sums array that we generate. And I have no idea what this syntax does, to be honest. I assume that this line 9 syntax creates an array of that size. That's some interesting syntax. Anyways, it creates that array and the
array.
So we're not editing the original array. We're just creating this new array and sort of generating it as we go. But then solution 2 is, rather than even creating a new array, we just keep track of those 2 elements that we care about. So the 2 before it. So what was the max sum at 2 elements previous to where we currently are? And what was the max sum at 1 previous to where we currently are, essentially.
Okay, I see.
And then, Oh, and I was gonna say, and then your solution is the maximum at the previous thing. I don't love the variable names first and second, to be honest, but the maximum at the previous element. So if we were at like 90, that's the maximum of if we had gone up to 75. Or we can add our current element to the maximum of 2 previous. So if we were at 90 again, we add array I, which is 90, to the maximum we found up until 120. Yeah. And then we just keep using those 2 variables. It's kind of a cool trick that you can use in a lot of dynamic programming questions, where you can get over one space if you just recognize that in this sort of like tabulation that we're doing, that we're never looking back to the beginning of the table. Then you can essentially say, okay, just don't even keep the whole table, just keep the most recent stuff.
Okay, I'll definitely keep that in mind. If you were to ask me the follow-up question, I would have thought of the tabulation method where you actually use an array. But the reason I didn't use that, use that after doing the recursion is because I thought that it's still linear space, so I wouldn't do that. You know what I'm saying? Because it's the space complexity is still the same. But in solution 2, I would have never thought of that.
Yeah, it's one of those things that, like, if you've never seen the pattern, you're never going to think of it. And then once you see the pattern, it does come up a decent bit. Yeah, the reason I didn't ask it, and I wouldn't have asked the follow-up in a real interview most likely, is if you had solved the problem essentially like solution 1, where it was not recursive, or it was iterative, but it wasn't doing that, I would have asked the follow-up of like, hey, are we actually using the entire, in this case, they call it max sum, but the entire memorization, or are we only using part of it? And that would sort of lead to the solution. But when it's solved recursively, I couldn't think of a way to formulate the question. So, yeah.
Okay. Yeah, I definitely understand that approach too. I'll keep that on board for the next DP question I do.
Yeah, awesome.
For sure.
But yeah, regardless, you did a great job. So nice work.
Thank you.
If you guys enjoyed that video, if you did, make sure to like and subscribe, and feel free to comment down below any other type of content that you'd like to see around here. And yeah, hope to see you guys in the next video.